Topic 26, Electromagnetic Induction, Part 3, AC Generator. Alternating current generators. AC stands for alternating current. Most electricity is produced using generator effect. The simplest generators and the types used in power stations produce alternating current, or AC. The structure of a generator is very similar to that of electric motor. In the case of electric motor, we pass current into the coil to make the coil turn. In the case of generator, we physically turn the coil to produce current from it. A generator is like an electric motor in reverse. As a coil is rotated, electromagnetic induction occurs, or power is generated. An alternating voltage is induced in the coil. An alternating current is drawn off through the two split rings, as opposed to the split ring commutator in the case of electric motor. The faster the coil is rotated, the greater is the amplitude of the voltage and current. In other words, bigger voltage and bigger current are produced. The higher is the frequency of the AC. Operation of AC generator. Now let's just focus on this side of the coil, and the coil is turning this way, anti-clockwise. We can apply Fleming's right-hand rule to this side of the coil. First of all, the motion is upward because it's turning that way. Field lines going from north or south is that way, and you find that the second finger should be pointing that way into the page. So the current flowing into a page here, across, out, along this way, through this slip ring, out this way, and through the resistor this way, all the way back. This diagram shows that this red side of the coil has turned through 90 degrees from horizontal position to this position. And at this position, this red side of the coil is moving parallel to the field lines, not cutting the field lines. Therefore, no EMF is induced and therefore no current flowing. In this diagram, this red side of the coil has turned through 180 degrees from that position right through to that position. And now this red side of the coil is cutting the field lines again, but downwards instead of upwards when it was in this position. So the induced EMF is in the reverse direction, and so the current is in the reverse direction. Once again, this coil is in a vertical position, and this red side of the coil is moving parallel to the field lines, so not cutting any field lines, therefore no induced EMF and no current flowing. As the coil continues to rotate, AC is produced. And you notice here that the voltage switches back and forth between positive and negative, changing direction all the time. And here we'll notice that when the coil is in horizontal position, the two sides of the coil are cutting the field lines most effectively. Therefore, maximum voltage is produced. This one here, that one there in the reverse direction, and that one. When the coil is in vertical position, the two sides of the coil are not cutting the field lines, so no voltage produced here, there, and so on. Question 1 says, the graph below shows how the voltage of a generator varies in time. Using the same set of axes, show how the voltage would vary if the rotational speed of the generator was doubled. Have a go and then check the answers on the next slide. Here it is in red. So the new voltage will have twice the amplitude and twice the frequency of the original. Work through this yourself, picking the right word for the right gap, and then check your answers on the next slide. These are the correct answers. This is for your general knowledge. Bicycle generator, and you can read through this carefully yourself and try to understand it.